This is going to be using units of measurement, part 2. We're thinking of the scale, the proportion of things to each other, and the quantities when we think, how do we communicate sizes? So sometimes sizes can be really huge, like the distance between planets. So we would communicate those units in astronomical units, like 150 million kilometers from the Earth to the Sun is equal to 1 AU. This object here is a pollen grain that might sneak into your nostril and cause you to sneeze. And that unit can be about 10 micrometers. So think of the prefix micro being one millionth of a meter, and nanometers is one billionth of a meter. And it's really hard to think about that. So think of a strand of Mr. Plumel's hair, if you can see that in the camera, is about 80,000 nanometers wide. So that helps you think. And when we think of the size of an individual atom, it's like a million times smaller than the strand of hair. So an atom might be 0.3 nanometers wide. So just incredibly hard to think about. One of the options in your choice board is to research the sizes of a range of objects. What are other objects besides pollen grains and atoms that are extremely small? And what units of measurement would you use to describe the sizes of to communicate the sizes of those objects? Put pictures and labels and stuff, and you might focus on how many grams an object has, what's the distance of that object going across, or distances between objects that are really huge, like between planets where we would use astronomical units, or the volumes of objects, like how much space different objects take up. Sometimes we can use units of measurement that combine more than one unit. Like if we wanted to calculate how the mass of substance compares to its volume. So the volume is actually written as a derived unit, which means we would say how many grams per liter is that substance. So when I drop a rock or something into this tube of water and I want to know the volume of this rock, I would look at what water level this liquid raised up to when I dropped the rock in, and then I would know, oh, it's occupying 1, 2, 3, 4. I might say 4 milliliters, and if I knew the grams, and it was like this rock was like 1 gram, it would be 1 to 4, and that would be like the density or the volume of. This is a function of density, and volume is a function of how much space something takes up. So a derived unit is something where we combine base SI units like grams and liters, mass, and per volume would be, so density is a derived unit. Density. Okay, so if the room is about 20 degrees Celsius, how might I convert that to kelvins? And I'm saying let's use some evidence from this example in our HMH lesson. We're on exploration 2, using units of measurement. So this example shows me that at 0 degrees Celsius, the water freezes, which would actually be 273 kelvins. So what I'm looking at is, let me get my draw tool here. Draw. Yay. So whoa, my lights turned off. Okay, they're back. Any amount of kelvins is equal, any degrees Celsius that I put is equal to, you would add 273 kelvins, right? So if it was 20 degrees Celsius, I would say 273, so it would be equal to 293 kelvins. So any degrees Celsius, to convert it, I have to add 273, because notice here also at 100 degrees Celsius, where water boils, you add 273 to 100 and you get that. For Fahrenheit, you would add 32 degrees. So something like that. Clear, all beautiful. Moving back, smooth transition. Oh, almost. Not quite. Okay. So, like I was saying, adding the rock into the tube meant I can calculate the formula and of density of this object by the displacement of the water level. And it's called the displacement method. But I don't need to do that for geometrical shape, where I can use a formula such as base times width times height would equal the volume of this object. And I know how much space it would be, so I would say 3.5 times 2 is 7, times 1.2 would be like 7. Sorry, I don't want to make the video too long, but you get the idea. So let's try, let's try to do some sample answers on page 13. So, smooth video transition. Look at that. Awesome. Am I actually smooth? No, I'm not. Here we go. Okay, I'm getting there. So, page 13, sample problems. Is this the one? Okay, let's do it. So, the volume of object A is, like we said, let's do base times width times height. 3.5 times 2 times 1.2 would be 3.5 times 2 would be 7, times 1.2 would be something like 8.4. Maybe that's correct. And let's see if it actually is. We'll put that down here. What did I say? 8.4? Okay. And then for object B, how many milliliters, if I go to say here, so this is at 17. right here where the water level is, and it goes up to 22.5. So uh, if you subtract those values, you would get 5.5, right? 12 minus 7. So it seems to be 5.5 would be our answer. Let's see. Okay. Oh, I'm having a better math day today. Let's practice some let's end the video here. We'll do part 3, density calculations.